Episode 11 of writing a 6502 assembler in assembly language. I'm sorry if the last episode was a little bit boring. Oh well, if it's boring, you can always skip it or look through stuff. You don't have to watch every minute if you want to watch it at all. In any case, I did fix some little problems with the scanner code yesterday. Mostly not problems of correctness, but just problems of it being kind of ugly and inefficient. Today, I'm actually going to try to print out the tokens. So I'm going to write a subroutine that will print out tokens. And this will allow us to verify that the scanner is working correctly. Of course, we haven't ever tried to actually execute the scanner, so I'm just thinking it's pretty unlikely that it's going to work correctly the first time, but we will never know unless we, try to get those tokens and print out what we got. So what I'm going to do first is just put in an error. We have this error routine that's supposed to print out errors. And the error routine has not been written yet. And I think it's very likely, whoops, we went too far. Here, let me just search for it. I think it's very likely that, actually, let me look for fatal because that's right by error. I think it's very likely I'm going to have to change the error routine later. But here's a good example of using it. We load in a pointer to a message, and then we jump to error and print that. We're going to print that out. Okay, and we also have a thing called error message. Let me go find that. But that's not what I want. Right there, yeah, see, it's going to print an error like this. Okay, it'll print error. So now let's look at for fatal again, because that's the easiest way to find this. Okay, so what I'm going to want to do here is I'm past a pointer in X and Y. I want to push that in the stack. First, I'll also put Y in A, push that, put X in A, push that. And now I want to go ahead and load this thing which says error and print that out. Okay? And now what I would actually like to do is print out the name of the file that this error message is in. And if you remember, that is stored right here in this F pointer. Okay? So let's go back down here. F pointer plus 1. So print that out. I would probably like to print out the line in which the error occurred. At the moment, I have no way to print out a decimal number. That's something that I will definitely want to do in the future. But I can at least print it out as a hexadecimal number for the moment. And remember, I have this variable called lines that counts how many lines we've done. And put XB was print a hexadecimal byte. So we print the high byte first and then the low byte. Okay. And then I think we're going to have to print a space. Actually, we probably need to print a space. Here as well, after the name of the file. Okay, good. And now we're finally going to get that error message we have back. and print that out as well. All right, and then we'll print a new line. So all of this code just to print out our error message. And now what we want to do is we want to basically, we want to just get input from the file until we get an end of statement character. Because we just want to wipe out the current statement. There's an error somewhere in the statement, we just want to wipe it out and basically flush the input till we get to the beginning of a new statement and then try to pick up from there. That should be okay. We'll see later. I mean, sometimes this leads to sort of cascading errors. For the time being, we'll just do it like that. So what we're going to have to do, and this is going to be a loop. Okay, get C, compare y to 0 to see if we have end of file. Okay, if we have end of file, then we will be done here. Otherwise, we're going to compare it to an end of statement. We want to look for an end of statement. That just reminds me, up there in the scanner, we didn't check for a comma as an end of statement. I'll have to go back and do that in a moment. If we get a carriage return, then what we'll do is I'll go to a place called error 1, which would be for new lines. Okay. If I get a new line itself, I will also go to error 1 because that's new line. Oops, error 1. Otherwise, I'm going to look for a comma. A comma is my end of statement character. If you want to have multiple statements in a line, you put a comma between them. Now, commas will also be used inside of a statement, for example, in addressing modes like this, right? LDA at X, we have a comma here. This is not an end of statement comma. Right, which means actually that the scanner probably should not return end of statement for a comma because it's going to have to return commas in this position. So I won't be going to change that. It would be nice to have a character which I could use as a good end of statement character, which is not a comma. But the problem with that is that there's really no good alternatives that are great. I mean, a colon maybe, but I think we'll stick with comma. It'll work. So if I get a comma here, now this is actually kind of a problem because, yeah, see, this is a problem because a comma is not necessarily end of statement. Well, what we can do is we can just blow away to the end of the line. Why not? If you give an error, we'll just remove all the input to the end of line. I think that sounds fair. Okay? So if it's an EOF, we'll go down to error 9, which would mean we're done with the error. We're done flushing the input. If we get a new line, we'll go to error 1. If we get something besides a new line, we'll just go get another character. So branch if not equal to error 0. Get another character. And here is error 1, which is the situation of getting a new line. What I'm going to do here is go ahead and just unget that character. Okay, and now I'm going to call scan. Like I know that there's either a character or a new line. So I'm just going to call scan subroutine just to eat up that new line. Basically, that's why I don't have to reproduce the whole logic to decide whether it's just a carriage return or just a new line or a carriage tune followed by a new line. Scan can handle that. So I'll unget this carriage return or line feed. I'll call scan to deal with that. And after it does, it'll return, an end of statement, but that's fine. I can just ignore it. I know that's what it will return. So we'll go ahead to return. Return from error. And at this point, it will have consumed input until it gets to an EOF. That's this situation here. Or it gets the end of the line. Right? And then it will return. So that will flush input once we get an error. Flush into the end of line or to the end of file. Oh yeah, we do need to do one more thing. We need to count the number of errors we get. Okay, and we'll do that here. Just inc the number of errors, return. Okay. And of course, we're going to need to declare this number of errors somewhere. Here, I can go up like this. There. All right. Actually, I can go down. There we go. I can put it right here. And for now, I think that's just going to be 1 byte. And the reason is that we can say if you get more than, like 200 errors, we're just going to stop. We're going to say, okay, we're not going to bother anymore because you've gotten so many errors, it's just not worth the hassle. Okay, so back up here. Now we have a way to print an error message. I mean, assuming it works. All right. This is funny. Jump error, and it's the thing right below us. Well, maybe this is a good place to put our... No, I think I'm going to put it up here. Oops. Okay, right here. Okay. So PR token is going to be print the token. So this is how once we scan and we get a token, we will try to print it out. And that way we can, this is just debugging code. It's to try to verify that we actually have a real token. Okay. So I guess the first thing to do is just going to be comparing against all these things here. And we will need some strings to print. I guess I'll just do it like this. Okay. So I'm basically just, reproducing the token here so I can print it out. It'll be easier to do it this way than to try to print out individual characters. Actually, create a message. Yeah, I just remembered colon is a valid token as well. I have to make sure that I allow a colon. Okay. Okay, and then numster, name, and EOF. Okay. So this is going to JSR scan, and it gets back the token in A, and the A register. So compare to end of statement, which is really just a new line. Basically, it's the end of line. Okay, so if it is an end of line, I'll just JSR NL. Okay, and then that it'll print a new line, and then jump back to PRToke up here again. I think I'm going to change this real quick to say if it is a TEOF, that is end of file. Okay, go here, PRToke 0, and that means this will be 1. If it's EOF, then what I will do, no, I'm not going to do that here. Okay, I'll just go down the line, all these things. All right, if end of statement, then I'm just going to print new line and go back up here. All right, we have LSH, RSH, blah, blah, blah. Okay, jump back up to get another token, and so on. Now this basically has to be copied several times for all of these things here. But I do want to do one other thing first, okay? So here at PRToke 0, I actually want to print each token like inside brackets or braces or something like that, so that they can be separated. And this goes up there. For that reason, after I print this out, I should not jump PRToke. I should not go back up here right away. I'll go to some label way down here. Which I'll just call PRToke 99 for now. And that will print the other, the right bracket, and then jump back up to PRToke up here. Okay. Now I can duplicate this, not this part actually. Oh, okay, that's a big screw up too, right? Because I can't load A here and then keep comparing A. I think what I need to do is just move the character that I'm trying to check. That is the token, move the token I got from scan into X. Okay, so now compare X. Okay, that looks better. So now I will copy and paste this stuff. Don't delete it. Okay, and then this here is prtoke1. This is 2. So if I got a right shift, then I'll print the right shift thing and go down there. Okay, so I have here less than or equal, greater than equal, equal, not equal. So 4 more things that look just like this. Oh. 1, 2, 3, 4. Okay. Less than or equal to 3, 3, greater than or equal to, and this will go to prtoke4, and here's prtoke4, and this would be token equals. All right, and this goes to 5, and here's 5. Now we're looking for not equals, and this will go to 6. Not equals, not equals. Good. Okay, and now we have to take care of these things here. The number, the string, and the name. Okay, prtoke6, compare X to tnum. Branches from equal to prtoke7. All right, now what we need to do is we have a number, so we're just going to go ahead and load the toke file and JSR to put XB. So we'll print it out as a hexadecimal number, which is fine for our debugging purposes. Okay, prtoke7. Let's see if we have a string. If it's not, we'll keep looking. If it is, what we want to do here is just go ahead and print out this is load, of course. Print it out in double quotes. Okay, and if you remember, our string is stored at locations at location 200. So the low byte of 200 goes there, which of course is just a 0, just like this. Okay, so that's 200. JSR puts to print that string out, but we're doing inside quotes, which themselves will be inside of brackets. All right, now we see, is it a name? name will be an identifier or something like that. Like at the moment, of course, we're not checking to see if it's some sort of, opcode or pseudo op or something. It's just something that has letters. We're at 9. Okay. And here we're doing basically the same thing. It's in the same place. It's in the buffer at location hexadecimal 200. But I don't want to put the quotes on it. I'll just print it out without quotes. That'll tell us it's a name and not a string. Okay. All right, in this case down here, it's some other token which is not one of these here. That is, it's a single character token. All right, we haven't checked for EOF yet, right? But I think I'll go ahead and check for EOF right now. If it's EOF, well, if it's not, we'll go down to PR token 10. If it is EOF, I'm going to do something a little bit special here. I have EOF message right here. I'm going to print that out. Okay, but now I want to go ahead and, as a special case, put my right bracket on the end of it. And then I will just go ahead and return. Okay. Otherwise, pure. This is where I do anything else. Now, in this case, every token is just its own ASCII character is the token. So all I have to do is just print it out. Put C. And then print out the right bracket and then go back up to the top and get more. Okay, so that should print out all of our tokens. What it should do is scan the entire file and print out tokens. That's the idea. So up here, here's where we have scan and parse source file. So JSR PR toke. And that should do it. Right, unless I forgot something. Will it assemble? Looks like it did. I didn't see any errors. It's printing enough stuff out that I kind of have to send it to the printer just to make sure. All right. No errors, looks good. Okay, and now, I just did think of one thing. I want to make sure that I return colons as a token. I think I might have forgotten that. Toke tab. Here it is. Yeah, colon is not in there as a token. So I'll just put it in. Why not there? Okay, so colons can be returned as a token. So basically what I need now is I need some sort of source file to run through. And I could try running through this source file. I could try, let the program read its own source file, which is not a terrible idea. But on the other hand, this source file and the source files that my assembler will accept are slightly different. So just assemble again, just to make sure that's all done. All right, let's see. Okay, AS0 is 33 blocks, AS9 is 15 blocks. I think what I will do, I know what I'll do. Let me just go here and get grab a little bit of this code here. Thinking, which one do I want to grab? Let me... there's going to be a ton of those, aren't there? Actually, let's look for this, get C0. Let me just grab this code here. Here, I'll just grab all of this. Okay. So what I'm doing is kind of like a copy and paste. I'm just not going to paste it anywhere. And I'll put this in test. Okay, no, don't delete it. Don't want that. Quit that. Load the file test. And now let's edit this to make it look like the kind of, you know, source file that MyAssembler will accept. All right. So in MyAssembler, these things will be BSS. So say, like, for example, BSS. And then we'll have an error. Okay, that's a label. Okay. So that's 1 byte. A label. Here, put a space there. Why not? Okay, 2 bytes for that. Took val. Right, and then lines. Yeah, at some point I'm going to. Let me check this out. I said narrower. Okay. Took val. I'm just hitting the tab key. Although actually I think this editor doesn't put tabs in, it puts in spaces no matter what. Okay, good. So that is BSS. This other stuff's going to be data. So you see how we just, this is how with the Orca assembler, how you define just, you know, uninitialized space, and MyAssembler will be like this. And then data, here's how you define this strings and stuff. This is data. And MyAssembler will be like this. So IO error will just be, now double quote, IO error. And then I can put \0 double quote. Right? And hex error will be bad hexadecimal digit period \0. And input \0. And so on. So let me just quickly convert this stuff to match the input that MyAssembler will accept, and then I'll come back and we'll try it out. Okay, that looks like about it. There's my uninitialized data, my initialized data. Now we have text, which is our code. The main difference is that we have the semicolons for comments. We have a colon after each label. Here, instead of having, we just write inbuff. And inbuff has a value, and that is the address of the buffer. We just write it there like that. Don't have to do anything else. Okay, that looks good. So we'll save that and exit. And now comes the big moment of truth, right? We're gonna go ahead and try that and see what happens. And I'll just do it to the screen first. Wow, it dumped a bunch of junk, which is not necessarily a bad thing. Okay, I see a little bit of weird stuff, but well, nobody expected it to be perfect. At least I didn't. All right, so let's look at the printout. Okay, we have some, it's claiming we have bad characters in the input. Okay. We have BSS, that's a name. We have in error. Now notice the colon is not getting printed out right. There should be a colon after in error, but it's not there. And also the equal sign is not correct. So it looks like the single character tokens are not being printed out correctly. Maybe that's something we can fix real fast. Okay, and that should be all the way down here. Oh, I think I know what the problem is. Yeah, of course. Our token is not an A, it's an X, and yet we just print it out here as if it were an A. We just called putc. All right, so what we have to do is prtoken, transfer that back into A, and then print it out. Okay. All right, print out our test. That looks better. In error colon dot equals dot plus 1, token value colon dot equals dot plus 2, and so on and so on. Okay, now it's saying we have a bad character in input. Hey, at least our error message is kind of sort of working, right? Error, file name test, line 7, bad character in input. Hex error, line 8, so on, so on, so on. So there's something it doesn't like about this stuff here. For every single one of them, it's failed. And these are basically all strings, I think. So we have to see what's going on there. Right, we get IO error, colon, and then bad character input on line 7. All right, one first thing to do here is look here and see, all right? What line is this? It says line 8. So the line count is off by 1, it looks like. But I'm guessing it's probably this double quote that is saying is a bad character. Okay, so let's quit this. All right, so when we go to scan, okay, Control X. Here you go. All right. The thing we should check is where the bad character input, that error is coming from scan 13. This is the bad character input right here. Okay, so I think I ought to go up here And at this point, I ought to look for places that we go to scan 13. And there's one. Okay, that's if it's a delete character. Other possibility is, okay, branch equal to a line feed. So this is the case we get the thing is here, we know we have a control character of some sort, because if it's not a control character, if it's a printing character, we'll go to scan 3. So the situation here is that we didn't get a character term, we didn't get a line feed, so it's a bad character. Okay, that seems fine. And single character tokens, go to scan 13. That's if we didn't find it in the single character token table. Okay. So that's the situation here. We have, okay, but it looks like it's failing on the double quote. So we need to go back up here and look at this. Okay. Is it a double quote? If yes, then go to get strl. And the bad character error is probably coming from get strl, not from here. Okay, and here it is. So it's saying that we got a, if we see a double quote, we come down here. Okay, and we take a 0 and put that here, because this is our index into the buffer. We get a character. If it is a new line, if it is EOF, go to get strl9, which is an unterminated string error. Then we check for a backslash and to look for escape sequences. If it's not, we just jump down here. If it is, we go get an escape sequence. And that can't return a bad character error. It just returns whatever it gets. If after the backslash we get an EOF, or we get, you know, something crazy, a bad control character, it'll just return that here. And then we see, okay, from get escape, did we get an EOF? If we did, then we go down to unterminated character constant. Otherwise, we say, did we get a new line? If yes, unterminated string constant. A character return, if yes, unterminated string constant. A delete, that would be get strl8, which is the bad character, which is the error we're getting, right? But I'm pretty sure we didn't get a delete character. Okay, if it's something less than a space, that is to say a control character, then it's a bad character. Okay, if it's a double quote, that's the end of the string, right here. Otherwise, it should be a valid string character. We get the index into the string, which up here was set to 0, but which will be incremented. Okay, we store the character we got into the string, into the text buffer. We increment this byte here. If it is not wrapped around, right, if this did not become 0 by this increment, then we go back to get strl0 right here and get the next character. Okay. If it did wrap around to 0, that's going to be in. We'll decrement it once, and we fall here to the case of end of string. We're going to put a null. We have to get this index into the text buffer out again, store a null there to null terminate, and call it a t-string and return. So I think what we're going to have to do here is at this point, yeah, I think I'll do it here. I am going to print out this character. So first I will push it. And after I'm done printing out, I'll pull it back. And I will first print out a left brace. And after I print the character, I will print a right brace. And I will pull it and push it. And here I will print it out as a number. So in between these braces, I should see that the ASCII values in hexadecimal of the numbers that are getting read in by the string subroutine here. Oh, goodness. Save. Save. Exit. Okay. What a load of mess is that? Okay, that's not useful. That is not useful at all. Let me search for this. Actually, real quick, stack P. Okay. Okay, so what I'm going to do here now is I have no idea why it printed out, like when I sent it to the printer, it did all that, it like overstruck everything, right? That doesn't make any sense to me because I'm just pushing the character, I'm printing a nice left brace, printing a nice right brace, right? Seems to me that should have worked, but it's just printing ASCII characters. Why would it do that? That's kind of mystifying. I think, let me just try for, let's just try not printing those braces. I can't really see how that would cause an issue, but still crazy up there. Okay. So push, load, JSR, pull, JSR. Oh, okay. That's a big mistake, and that might be the issue there. Right, so I need to pull the thing, then push it back. I was pulling it, then doing a JSR, and then pushing it, which was pushing the wrong thing. And okay, well, let's just try that. Test. Okay. That's a little bit better. It looks like when it gets to the end, it just starts printing on top of itself or something like that. Well, let's look at the one we can see. Okay, it gets all the way. 2E is the double quote. I'm pretty sure. Well, let me look it up real quick. No, 2E is the period. Okay. And 2F is the slash. Okay, and 49 is uppercase I. Uppercase I slash OIO space ERROR period 0, and it says bad character and input. This here also gets 0, 0, bad character and input. Oh. Is it saying that this 0 here is a bad character in the string? Yes, I think it is. It absolutely is. But actually, I don't want it to be a bad character in the string as long as it comes like this. Ah. Okay. So yeah, this is something I did, which turns out to be a little bit wrong. I think even did this off screen. I think I can get rid of this stuff. If I have to put it back, I'll have to put it back. No, what I did was that I check here for an escape sequence. If I get an escape sequence, I then run through this whole thing of checking for stuff here, right? But actually, if I get a 0, a control character, a new line, or any of that stuff that's not given as an escape sequence, it's bad. But if it comes as part of an escape sequence, it's fine, right? In other words, \n should insert a 10, ASCII 10 for line feed in there, right? And that's fine. But I don't want an actual new line in the string. In other words, what I'm trying to say, I think it's maybe clear, is like, hello, \n, that's fine. But hello, new space, that's not fine. I mean, hello, new line, like this. This one is okay, this one's bad. So it shouldn't go through all this checking here if it's through get escape. So what I'll do here is I will copy this out. All right. I think that will be good. Delete, yes. Okay, so if I get an into file, then I go to down there for unterminated string literal. Otherwise, I now check for control characters that I don't like. Okay, if I don't get a control character, then now I will check for my backslash. Okay, it looks like this can go away completely. Okay, if I don't get a control character, I'll look for my backslash. If I get a backslash, and this one here would then be that would be there. Okay, if it's not a backslash, go down here and see if it's a space or a double quote or whatever. Ah, but actually backslash double quote is fine. So actually these things have to move too. Backslash space being a space. Oh, it's saying if it's a control character less than a space. Okay, well, hang on. So this actually has to go up here, but I'll just type it in. Okay. That's a control character of some sort. If it's less than a space, go down there. And now I have to say if it is a double quote character, that's going to be end of string. Which is get strl2. So these things go away. Otherwise, I think I'm just putting it back the way it was before I changed it off screen. So good. Now, at this point, after this line, we know it's some character that's allowed to be in the string, right? So here, it's a character that's allowed to be in the string unless get ESC returns something horrible. So now we see, is it an escape sequence? If not, we go here. If it's not escape sequence, we just actually go right here. Right there. If it is an escape sequence, we look for the escape sequence, and if it turns out to be an EOF or something horrible, yeah, EOF. Just thinking. Yeah, EOF goes to unterminated string literal, and we do. The thing is, if it's a new line or a carriage return or one of those other control characters we allow, that's great. If it's not, if it's some other control character, we don't want to allow it. But right now, for example, if someone had entered backslash and then they just typed a control G into the file, get ESC would return that as a control G. But we don't want to allow that. So what should... Yeah, I think get ESC probably should only allow certain specific things to come after a backslash. And if those certain specific things don't come after a backslash, then it's just going to return that. It's going to unget the bad character after the backslash and then return the backslash. So that will be a slight change. I have to do that to solve this little problem completely. Okay, so anyway, if we get escape sequence come with the end of file, it's that. Otherwise, it's something good and we can put in here. Now let's go solve that little problem. What we're going to do here is say, okay, at this point where we're looking through the table, the ESC tab, if it finds that it's not, the character it's looking for is not a table, it'll return here and it will just load that. Right now what it does is it just loads that character that's not in a table and returns it. We don't want that because it could be a control character or something like that at that time. Instead, what we want to do is we want to take that character that was after the backslash, which is not a valid escape sequence, and we want to unget it. Okay, we haven't modified y here, so we can just go ahead and JSR unget. And now what we will do is we will return the backslash. So if we have an escape sequence, for example, that has, like escape \z, well, z is not one of the valid escape sequences. So now when it finds that there's no z, there's no \c is not in this escape tab, this esc tab here, then it will unget the z and then return a backslash. And for a character literal, that will then cause a problem because after it returns the backslash, it will not find another single quote, so we'll say, hey, this is a bad character literal. For a string, it will just come in as 2 bytes, backslash and z. I mean, I have another option of like throwing an error and saying, hey, this is a bad escape sequence. But I just think that's probably unnecessary. Now I just have to go down to my esc tab and make sure that the things that need to be in there are in there. That is right here. And at the moment, they're not. Okay. So let me get rid of this. I'm just going to continue on the next line. So for example, a backslash in the table gives you a backslash. Okay. I don't even need, I could just be like this, right? And a quote, get you a quote. A single quote, get you a single quote. That is the single quote. I'm pretty sure I can enter it. It's decimal 39 or hexadecimal 27. Okay, so I just put it as hexadecimal 27, 27. You get backslash single quote, you return a single quote. So backslash returns backslash, backslash double quote returns double quote, and backslash single quote returns single quote. And that is all, I believe. All right, so then 0, 0 for the end of the table. All right, this is kind of ugly to see, but if you get backslash 0 as an ASCII 0, a character 0, then you return 0 as a value. If you get backslash t, return 9 as a value, which is ASCII 9 is the tab character. If you get backslash n, you return 10 as a value. Hexadecimal A is decimal 10. If you get backslash r, you return d, which is 13 as a value. If you get backslash, you return backslash. If you get backslash double quote, you get double quote. Backslash single quote gives you single quote back. And that's that. Let's try that. I have an error. What is the error? Unresolved reference get stir 8. I know what the problem is. The problem is we don't have a label called get stir 8. It's get stir L8. Okay. That's all right. Be nice if I could type. Okay. See? Now the stuff works. Well, we do have a problem here. But this mostly works, okay? Okay. Escape tab, we get 0030. Let's look at what this escape tab looks like here. Escape tab colon, and then we have a character constant. So this one, these are the string constants here, they all seem to work. These are character constants here. Oh, by the way, in that printout, we can't see this 0 here in the string, but that's okay. I'll assume it's there correctly. The character constant seems to not work. Right? What was the, did I delete it? I guess I did. That error message was from my program. Oh, I see. That character constant, you're right, exactly. That character constant is a number, hexadecimal 30, which is an ASCII 0. So that's correct. But then it says bad character and input. Okay? And so the bad character it's getting is that what's in the file is actually a comma after this character constant there. See? Okay, it's a comma followed by a decimal constant, a comma, and so on. Okay. And here's the problem, I think. We don't have comma in our token table. So if we just insert that, we should be better off. Oh. Well, wait a minute. Did I just put that in the code that's not actually being assembled. That's kind of dumb. But, you know, that's me sometimes, kind of dumb. Here we go. This is the place we need to put it. Ah, what am I doing there? Felt like I was using VI for a second. All right. Okay. So A okay, so this is A. Okay, this is, I guess, T returns a tab. N returns an A. And then what's this? Why is there no, what is 2C? Well, let's go take a look. Oh, I see. 2C is this comma. So it's returning this as a number with value A. It's returning this as a comma, which was 2C. And then it sees an R. The R itself should not be a problem. That should just be a name. And then it sees a single quote, which it thinks is a character constant, and then a bunch of mess, okay? Because the problem is this one here should not be there. But let's not that. Let's try again just to. Yep. Okay, that's it. A bad character constant. That's right. That's exactly right. It is a bad character constant. So that's not actually a mistake. That just needs to go away. Like that. Okay. Now we'll try it again. Okay, that all looks nice. All right, now we have a problem with text, bad character and input, and then we have get C. Oh, this is the, you know what this is? This is the comments. I haven't written any code to handle comments, so it sees that semicolon and it says bad character and input. So let's look at the code now. Load peak C 0 plus 1. Okay, there's another comment there. Okay, so right here, JSR read, nbuff, BCC gets C1 here. This is probably a problem right here, unless it's just another comment. But yeah, actually probably it is. Compare to this number, hexadecimal 4D, and then this is probably just a comment. Okay. Okay. It all looks good, as long as these are just comments here, okay? That is 1, 2, 3 lines of comment there, then 4, 5, 6, 7, 8 comments. If those are all, if that's all it is, then all this stuff looks like it's correctly tokenized, which is great. I just need to, of course, fix the comments, right? 1, 2, 3 lines of comments, 4, 5, 6, 7, 8. 8 comments. That all looks nice. This comparison is to 4C. Let us click here. Yeah, so right after JSR read nbuff, we have compare 4D. Why 4D? If it was 4C in there. Yeah, it definitely says 4C here. But it comes out as 4D. And this should be 0002 in there. Okay. So there may be some issue there, or that looks like there is some issue with this. You know what probably is? It's because it's just one higher. It's probably that I forgot to clear the carry before I added in the value of the digit. And if you don't do that, it's going to add a 1 for the carry in there. Okay, let me go quickly take a look at that. Load another file. All right, and we're looking for, oh, not that, here. Get hex 0. Here it is. Okay. So here's where we, well, there I did clear carry. So we'll have to look into that because right, I push, I subtract. Of course, it is possible this subtraction is, there's something, this whole calculation here is slightly off. So for example, I got a capital C. Okay, I'm looking through here. Is it less than a lowercase a? No. Okay, is it greater than or equal to lowercase a and less than lowercase g? Yes, go to ABC dig. Okay, and to check this, I need to look at the uppercase C. The uppercase C is hex 43, which is 0, 1, 0, 0 for the 4, and D is 1, 1, 0, 1. So that won't affect it at all, which is correct because it's supposed to turn lowercase letters into uppercase letters. So it will still be an uppercase C with value 67. Now it subtracts 6, but when it came here, it was with carry clear. So it's actually going to subtract 7. Okay, so it will be 67 minus 7 is 60. Okay, and now it will subtract ASCII 0 minus 1. ASCII 0 is 48, so it will subtract 47. So it will be 60 minus 47 is 13, which is wrong. That's a D. Okay, so if it's a C, it should be turned into 12. So my thought process was this when I went through it, that uppercase A is 65. Okay, so if I get here and I have a 65, yeah, it's related to this thing here. So 65 minus 7 is 58. And then I was thinking I would subtract 48 here because carry is clear. But after this subtraction, carry is actually not clear. When we go to deck dig, carry is clear right here. But after this subtraction here, carry is set because 6 is less than the value of whatever the character is. So actually, I need right here to go ahead and clear the carry again. Because the whole point is coming to here, the carry should be clear. That's why there's this -1 here. So after this subtraction, though, carry was set because we did an underflow. The value in the accumulator was greater than 6. So when it subtracted, it didn't need to borrow anything in the future. So therefore, carry was set. So we have to make sure it's clear again. That should solve that problem. And we'll see, yes, 4C now, exactly. That is now correct. Okay, so I'm going to call it here because it looks like the scanner is doing a good job so far. Now we have to do more testing of it, and I have to go through and I need to go ahead and put the code to skip comments because I don't want to see this nonsense, and we need to skip comments anyway. But as of right now, it looks like it is doing what it's supposed to do. And so next time we'll put in code to skip comments and not throw errors when we see a comment. And we will do more testing of the scanner. I'm going to create a test file off screen that will have like pretty much everything that could possibly be in a file, and make sure the scanner works correctly. I mean, I'll show you how I test it, but I'll make the file off screen and then come back and test it, and we'll see. But it looks like the scanner is working well, and if it is indeed working well, we don't find any other problems, then it will be time to start using the scanner and parsing the input. Oh, well, actually, that's not quite true. I first need to go through and make sure that the scanner returns keywords for keywords. In other words, STX should not actually be returned as a name. It should be returned as a special keyword, right? Because it's an opcode, and the pseudo ops that we're going to use should be returned as well. Which what we'll do is we'll just take those names and we'll just do a binary search in a table and figure out if they're in there or not. If they are, we will return some value which tells us it's a special keyword. If not, the return is a name. So once the scanner is working, maybe next time we'll write a binary search for strings, and that'll be nice. So until then.